This video is going to be on chapter 12, which is on linear regression and correlation. So the relationship of that regression feature. So quick review of linear functions. Y equals mx plus b is the slope-intercept form, where m is the slope. So that's how it rises, how fast and the angle. And then b is the y-intercept. So that's where the function crosses the y-axis. X is your independent variable with an exponent of 1. So often x is time when we're talking about real life functions. Exponent is 1, so it's written with an x and it has that imaginary 1 there. It's a constant rate of change, so it's consistent through the whole thing. Positive graphs increase as it moves to the right. Negative graphs decrease as it moves to the right. And when it has a slope of 0, it's a horizontal line, stays flat as it moves to the right. Now, all of these graphs have arrows on both ends, but I was just drawing that to show you. Linear is a straight line, there's no curves. Y is your dependent variable. So this changes based on x. So it depends on x with what happens. So here's an example. Emma's Extreme Sports hires hang gliding instructors and pays them a fee of $50 per class, as well as $20 per student in the class. The total cost Emma pays depends on the number of students in the class. Find the equation that expresses the total cost in terms of the number of students. So they pay $50 per class. So just for teaching the class, they get $50. That's your y-intercept, because that's what you pay no matter what for teaching the class. Then you pay $20 per student. So depending on the number of students, you make more money. So $20 per student. So you would have y equals $20 per student plus the $50 for class. There's your equation. If we put that in function notation, you might say the cost per student is $20 times the number of students plus $50. Those are both the same equation. One's just y equals and one is function notation. So here's a you try. Pause the video, see if you can answer the question, and then check the video out when you're ready. Svetlana tutors to make extra money for college. For each tutoring session, she charges a one-time fee of $25 plus $15 per hour of tutoring. A linear equation that expresses the total amount of the money Svetlana earns for each session she tutors is y equals 25 plus 15x. What are the independent and dependent variables? So independent is what's happening. So that's your time. So that's your hours of tutoring. That's your independent. So the dependent is going to be how much she's making. That's your money. How much she makes depends on the hour she tutors. And then what is the slope? So how much does she make per hour? So $15 per hour is the slope. All right, so that's your quick review of your linear equations. Now, scatter plots. So scatter plots are a way to plot data, to display the relationship between two variables. So if we're comparing our age in years, that's our x, because that's our time, it's our independent variable, versus the vocabulary size in words. So how many words do they know at what age? And then we plot those. So if we said 3, 655, that'd be this point. 4, 1098, 5, 2463, 6, 3195. So we took an age, how many words they knew, and we put them on a graph. That's a scatter plot. It visually shows the relationship. So because it's increasing as it goes to the right, it's positive. If I connected those, it would be kind of a line, so it's linear. So together, by putting the dots on there, we see we have a positive linear relationship. The more data you have, the more clearly you can see a relationship. If you have 100 dots, you can see a deeper relationship, or if there isn't one. Your calculator will plot that for you, just like it did with our histograms and our box plots. So just like before, if you hit the stat button and then enter, you go into the menu, you put your X, your independent variable in L1, and you put your dependent variable in L2. Remember, if you need to clear, you arrow up to highlight L1, hit clear enter, same thing for L2, then type your data. So if I put the hours in L1, all right, so 5, 7, 9, 10, 11, 12, and then we put the points scored in L2, 15, 22, 28, 31, 33, 36. 15, okay. That's how we get the data in. Now to do the scatter plot, so this is scatter plot, you're going to hit second, which is the blue button, y equals, and then enter if you have the calculator or the app or the website. You don't need enter if you have the app. Turn it on if it's not on already. Then choose the scatter plot for the type. So the scatter is the one that has the dots. Your X list should say L1. Your Y list should say L2. To type L1, you would hit second 1. To type L2, you would hit second 2. Choose the mark you want. That's up to you. Then to do your graph, you're going to hit the zoom button, which is the top middle gray button, and go down to number 9 for zoom stat. Then you'll see the graph. So your graph should look something like this, where you have those squares. It goes up to the right, so it's positive, and it looks to be about like a line, so it's linear. So those are some different relationships that you see. Now, different patterns you might see are linear. So linear would be if the dots fall in about a line. Exponential, they might fall in a curve like this. None, you would just have a whole bunch of dots that don't show any relationship. Positive, the dots would rise to the right. Negative, they would fall to the right. Strong, they're close to a line. Weak, they're more spread out. So you can see this is still kind of a line, but they're more spread out than the strong ones. That's how you might define the patterns you see. So that is your information on your scatter plots. For 12.3, the calculator will also find the equation that you can use for the line of best fit. So we call it line of best fit. We call it the least squares line. We call it the linear regression line. Those are all of the same thing. What it's going to do is it's going to use the data you put in the calculator. It's going to make a scatter plot. And then it's going to make a line that fits the data as close as possible. And then you can use that equation to make predictions about the data. So just like before, we're going to enter our independent variable in L1 and our dependent variable in L2. So stat, enter. We're going to go up and clear out the old data. My goodness. Stat, enter, clear the old data, and then put our third score in L1 and our final score in L2. So 70, 67, 75, 66. And then our final score in L2. Sorry. Third score was an L1, final score an L2. All right, 159, 51. Okay, so now that data's in there, we're going to make the equation. So we're going to click the stat button again. And then, just like before, we're going to arrow over to calc, like we did for our one variable stats. But we're going to go down to number 4. It says lin reg. So that's our linear regression. And then notice AX plus B. So it's got the slope-intercept form. So hit enter. Our X list is L1. That's saying, hey, our X variable is in L1. Our Y variable is in L2. And then hit enter. So our frequency list should be blank. The store equation is blank. And now it gives us an A, 4.827. It gives us a B, negative 173.513. And it should give you an R squared, 440, and an R. If your calculator does not have an R squared and an R, you're going to follow these steps, and you will only have to do it once. So if no R squared and R, you're going to type second 0, then the X negative 1 button. Use the arrow down until you find diagnostic on and hit enter twice. So second 0, X negative 1, it brings you to the D's. Scroll down until you see diagnostic on. The app doesn't have it. The calculator online might. And then hit enter, enter. It'll bring you back to the main screen and it'll say diagnostic on done. You'll only have to do this one time. Now, if you do this again, stat, over to calc, choose number 4, hit enter. Now you'll have the R squared and the R. We'll talk about what those are in a second. So this gives you the equation. A is the slope. B is the y-intercept. So our equation for this line is y equals 4.827x minus 173.513. That's the equation. So the question is, can you predict the final exam score of a random student if you know the third exam score was 75? Well, since the third score is our X, we just plug 75 in for X. And type that in the calculator. So 4.827 times 75 minus 173.513. And we get 188.512. Then we do that again for 66. So 4.827 times 66 minus 173.513. We get 145.069. Then we do it again for 90. 260.917. So those would be our 3 predicted scores based on that data. Now, does that mean it's guaranteed? No, that's just the prediction based on what this person has seen. So why don't you pause the video and do the U-try, and then get the video going when you're ready to check. All right, we're going to put the depth in L1, the dive time in L2. So stat calc 4. So the equation should be negative 1.114x plus 127.238. And then they want us to predict 110. So negative 1.114 times 110 plus 127.238 gives us 4.698. All right. Now, a residual. So a residual is the distance between the point and the line. So on a graph, so if I hit y equals, I'm going to type this pink equation. Negative 1.114x plus 127.238. And then I'm going to zoom to that scatter plot. So those dots are the dots in this table. And the line is this equation. The residual is the distance between one of those dots and the line. The way you find that, ROP, is the residual equals the observed minus the predicted. So the observed is the actual data value. And the predicted is the value from the equation. So this y hat means the equation value. Okay? The correlation coefficient, that's the R that we got in this equation. That tells you if the line is a good predictor. So that's the strength of the line. So back when we were talking about the strong and the weak, the closer R is to 1, the stronger these dots are. So R is between negative 1 and 1. So if it's 1, it's a perfect line. All the dots end up exactly on the line. It's positive. If it's negative 1, all the dots end up on the line and it's negative. If it's 0, there's no linear relationship at all. The coefficient of determination, that's R squared, that's the percent of variation explained by the equation. So you could say, like if it's 0.82, you'd say 82% of the data is described by the line. So those are those two things that we turned on if your calculator wasn't doing it. So for 12.5, this is that same data we had in the example 1 from before. So before I deleted it to do the U-try. 75, 67, 70. You can pause the video if you need more time to type. But you're going to have your data, 175. And then you have your equation, 163, 126. So you have your data, find the linear regression. So we do stat calc 4. Our equation is 4.827x minus 173.513. What would you predict the final exam score for someone who scored a 66? So we plug in 66 for x. I did that wrong. Close parentheses. There we go. So we would predict they got a 145.069. Someone who had a 90, plug that in for x. $827.90 minus 173.513. We'd predict 260.917. So just like we talked about before, that's over there. The difference is this 90, these data points go in the 60s and 70s. So 66 makes sense. 90 is way above these data values. So it doesn't necessarily make sense to plug this in. Or if you do plug it in, you want to use it with caution. You want to think, hey, I don't know how good this prediction's going to be because it's so far outside of the original data. So either use it with caution or say, I don't trust that prediction. So keep in mind your range, your original range of data when you're plugging things in, because your equation's only good for data that matches your original data set. And then the final part of chapter 12 is outliers and influential points. So outliers are any data that's away from the regression line. Usually we talk about things vertically, but it's anything that's far away from the data. They have larger residuals. Influential points are away from the data, usually horizontally, but what's important is they affect the regression line. An outlier may not affect the regression line because there's enough other pieces. An influential point definitely affects the regression line. A data point can be both. That is chapter 12. Let me know if you have any questions.